Good evening and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And today we're looking at example 11 of Pure Mathematics 1 and on page 124. And part A of the same example is asking us to sketch the graph of y is equals to the cosine of theta in the interval of negative 360 all the way to positive 360. And what we need to do is we just need to refer the graph that we have constructed in the previous video. But even if we don't have that, we know very well that we understood the maximum of y is equals to cos theta is 1, and the minimum of y is equals to cos theta is negative 1. The graph will oscillate between the two. And of course, we know very well that the cosine of 90, or rather the cosine of theta is 1, the cosine of 0 is 1. Then we have our 90 here, we have our 90 there, we have our 180 there, we have our 270 degrees there, and we have our 360 degrees. We have our negative 90 on the other side, negative 180, negative 270 degrees, and of course negative 360 degrees. This is the range which theta must dwell. We know very well from the previous video that the graph of y is equals to cosine theta. It crosses the x-axis at negative 90. It crosses the x-axis at 90, and from there you keep adding 180 again to 70, and you keep subtracting 180 again negative 270. If this graph is coming this way, then it is sure that it is negative 1 at negative 180. The value of y is negative 1 when theta is negative 180 degrees. And that is exactly what happens when we need to construct this graph, and of course it is 1 over there. So the normal flow of the graph demands that we are having negative 1 when theta is 180 degrees, and you can see the minimum is negative 1 and the maximum is positive 1. And this is the graph of y is equals to the cosine of theta for this range of negative 360 degrees all the way to positive 360 degrees. And that is as far as part 1 is concerned. Now, the second part of the example 11 is sketch the graph of y is equals to sine x in the interval negative 180 all the way to 270 degrees. And it goes without saying, we just have to have the y-axis and of course the x-axis. And let's have 0, and we are going to have 90 degrees, we're going to have 180 degrees, and we're going to have 270 degrees. And because that is the range, we need not to go beyond that particular point. And the other range is negative 90 and negative 180 degrees. And that is just like it. We know very well that the sine of 0 is 0 degrees, and the sine of 90 is 1. Again, the minimum is 1 and the maximum is negative 1. So the sine of 90 is 1, and of course the sine of 180 is 0. We know very well that the graph of y is equals to sine x. It crosses the x-axis at 0 plus 180, 180 plus 180. Then we go to 360, but of course that is outside the range. So from 0 minus 180, then that is when again it crosses the x-axis. So if you're moving from this particular point, we just need to have a normal kind of flow, and that is it. If you are to continue further, we must go that way. But of course, when x is negative 90, again y is negative 1, and that is just like it. This is a normal graph of y is equals to the sine of x. Having said that, we now get to the part C of the question. Part C of the question suggests that if sine negative 30 degrees, and we can already see it here, the sine of negative 30 degrees, if we were to talk about it like negative 30, the sine is negative 0.5, that is true. Negative 0.5, that is true according to this equation. Use your graph to determine two further values of x for which sine x is negative 0.5. Two other values of x for which sine x is negative, of course, 0.5. And I'm presuming that, or I'm thinking that this question is set in part B, in having put part B into consideration. And why I'm saying that is because of the limit. The limit, upper limit is 270 degrees, and the lower limit is 180 degrees. So in my very straightforward approach to this question, I'll simply pick my ruler. And draw a straight line where y is negative 0.5, and I will, within that, I will get, this is one value of x which is negative 30 degrees. This is another value of x which is, negative 150 degrees. Negative 150 degrees. This is another value of x. This is another value of x which is 210 degrees. And if you are to move further, this is another value of x which is 330 degrees. So you can say confidently that x is equals to, yes, minus 150 degrees. X is equals to, yes, minus 30 degrees, which is already given, and x is equals to also 210 degrees. And those are the possible values of x, because beyond 270, then we are outside the range. But I want us to just give this question a different approach, and we are going to use the unit circle as we know it. The unit circle as we know it is simply this, that the graph of the sine of negative 30 degrees, this is 30 degrees, is negative 0.5. The sine of negative 30 is negative 0.5. And because we know, all science teachers complain that sine is negative here and sine is also negative here. So this is 30 degrees also. So we actually know that that is another possible angle. And what is the measure of this angle? Negative 180 plus 30. Negative 180 degrees plus 30 degrees, which is easily negative 150 degrees. That has been realized. Again, we could also evaluate that if we followed this direction, are we going outside the range? Of course not, and let us see. So this direction talks of positive 180 plus 30. X is also equals to 180 plus 30, which is 210 degrees. So yes, the possible values of x is negative 150 degrees and 210 degrees, and that question has been solved. Remember, we have given it two approaches, the graph and of course the unit circle. Again, I recommend that you visit my YouTube channel, Pearson and Excel International Maths. Subscribe and share widely, and of course like, and let us work together. All right.